Hello, hello, hello. So today, I would like to do a revision with you again. It seems you struggle with quadratic functions. However, you as a 2021st, the first KSSM syllabus Form 4 student, you should be able to answer this kind of question, which is K-bar question like this. This is one of my questions on from my AdMaths teasers number 2. You will see this water rocket project question. You see, in a water rocket project, a parabolic curve is formed from A and B. So the projectile motion begins on the cliff with a height. Okay, we try to just highlight some terms. Height equals to h equals to 10 meters. We have to denote the projectile equation, which is this one, as a x1t, where t is a time taken for the whole journey, and x is a vertical displacement of the water rocket. Because if you have a rocket, when you shoot the rocket out of the source, you will have a horizontal displacement and also a vertical displacement, which combines together in terms of vector as a resultant vector. Like this, you will learn this kind of thing like vector in the field, in the next syllabus, which is after the coordinate geometry. But right now, we just want to have a look on how the projectile of water rocket partially looks like. Okay, now additional information states that the maximum height h max is 12.25 meters. Average time taken to hit the ground, which is actually the TF. F represents the final time recorded during the end of the journey when the water rocket hits the ground is 5 seconds per shot. Construct the projectile equation. The first question, yes, we have to construct them by using these highlighted informations given. Okay, so since it begins at t equals to 0, your xt, okay, when t equals to 0 is 10, okay, on a cliff with a height of a h, okay, it means when you have for example, a cliff like this is the height h equals to 10, and it forms a parabolic curve like so, and done. So this is a parabolic curve that you're supposed to get, and this is the vertex, okay, of the parabolic curve, and this is the remaining piece of the parabolic curve, which I do not show because this is where the rocket projectile motion starts, okay, at the height of 10. Okay, this is when t equals to 0, and this is when t, okay, equals to something. So we need to find that something, and this is when t equals to 5, okay, because here shows the ground, okay, this is the ground, okay, when the rocket hits the ground, t equals to 5. We need to find t equals to, we don't have to find immediately what t equals to something, so but we know that the maximum height is this, excuse me, okay, the h max, very important, equals to 12.25. okay, now we use the first piece of information, which is the maximum height equals to 12.25. Now, how are you going to construct the projectile equation first? We use a general function like this. So xt equals to generally a times t minus p squared plus q. This is a general parabolic function with a vertex form. Okay, now the first piece of information, which is h max equals to 12.25. It means, okay, this implies that q equals to the h max. Okay, well, according to the quadratic function, so we try to change the form into a t minus p squared plus 12.25, and then now we have left the a and the p. So how are we gonna solve for this? So in the beginning, I have mentioned that when t equals to 0, x equals to 10, we just substitute this. So we use this idea in in solving the a and p. But this is just one of the equations. Later we will use the another one, which I will mention later. Okay, now when t equals to 0 equals to 10, hence 10 equals to a times 0 minus p, you will get negative p squared plus 12.25. This is the very second one, and you can actually change them into the desired form. Like I will use the blue one as a desired form, okay, into the p squared plus 12.25, which is the very first equation. I'm gonna label it as 1. Okay, the second piece of information is, as you can see, the average time taken to hit the ground equals to 5, which means when t equals to 5 and it equals to 0, because initially when t equals to 0, you have positive 10 because of the height of the cliff, and when you hit on the ground, you minus 10. So 10 minus 10 equals to 0, obviously. Now you will have again the same function, the general function on the top, this general function, okay, with a and p inside. But this time you use t equals to 5, so a should calculate first. A times 5 minus p squared plus 12.25 equals to 0. In the end, you will expand them. Okay, no worries. Just expand them as usual. Plus 12.25 equals to 0. In the end, you will get something like ap squared minus 10ap plus 25a plus 12.25 equals to 0. Well, this is not really the desired form that we want to have. So the only way we can solve this equation, okay, simultaneously, is by actually taking the value of, for example, a from 1 in terms of p. So we're gonna convert this into, well, a p squared, isolated a p squared, and then 10 minus 12.25, which is equal to negative this, and then you will have a equals to the negative 2.25 over p squared, and then you will substitute the value of a in terms of p. You will have this, okay, you convert them in terms of p, 2.25 p squared, p cancel out, and then negative a p times negative 2.25, and then p squared, very interestingly, and then plus 25 times negative 2.25 over p squared, and then plus 12.25. 0.25 equals to 0. You will have a 10 as a result, and then you will have here, well, 22.5 but positive, and then over p, and then you will have a negative, well, in this case, it's a very complicated algorithm. So you will have negative 56.25 over p squared and equals to 0. Okay, now you can actually form this in quadratic equation by multiplying on both sides with p squared. Okay, and hence you will get 10p squared and then plus 22.5p and then minus 56 comma or 0.25 equals to 0. And you can actually solve using any kind of formula. You will get quadratic formula, and hence you will get p equals to, well, p1 equals to 1.5 or p2 equals to negative 3.75. Okay, no worries, we just go for it. We have no idea whether or not we can accept only one value. So this is for solving p, and for solving a, we have to use the substitution here. We know that, recall back, a equals to negative 2.25 over p squared. If we use, well, in case of p1 equals to 1.5, our a1 equals to negative 1, obviously. And then if our p2, I shouldn't use it here, if our, I'm so sorry, I don't know why. If our p2 equals to, in this case, negative 3.75, and then you will have, I'm gonna make sure the value is, you will have a2 equals to negative 0.16, interestingly. Okay, well, if you have these values obtained, you will have a1 and then a2 and then p1 and then p2. We're gonna use for each pair a1 p1 in this case, so we construct the quadratic function using a1 and p1. We will get negative and then t minus 1.5 squared plus 12.25. Okay, or you will have negative 0.16 of t minus, well, plus, sorry, 3.75 squared plus 12.25. Well, how are we gonna to determine which pair, okay, of this? This is the pair 1, so pair 2, okay, for a1, p1, and this is for a2 and b2. Okay, now how are we gonna see the logic behind each of the equation? So we know that t is a time, so can time, the range of a time should be greater than 0. Okay, you can't have a negative time. So in this case, we know that if t minus 1.5 equals to 0, you will have a maximum height obtained, which is 12.25. So t must be equal to 1.5, and this is positive, which means the pair 1 is correct. Okay, it's correct, so I use the green pen to show that this is correct. Okay, the second one, you have t plus 3.75 equals to 0. So if your t plus 3.75 equals to 0, then you will have a maximum height again. But however, your value of t is wrong, it's illogical. because your t equals to negative 3.75, which is wrong. We do not have a negative type, so the pair 2 is wrong, and hence we use a pair 1 as a xt. Okay, we use a pair 1 as a xt, which is if we have a function of x1t, okay, recall back, it equals to this projectile equation. And QED.